Oh, hi there. Thanks so much for showing up for your learning. It's Tutor Grant from the Math Mastery Academy, and we're looking at question 23 from the 2022 Pascal contest. So in this question, we need to work with our circle sectors. A circle sector is like, we zoom in here, we see one beautiful circle sector, that like piece of pizza right there, okay? And in fact, we're interested in finding this angle x. Okay, there's some angle x that we can open that circle sector up and get the proper ratio between the two shaded areas. Now, circle sectors are very interesting. If you were like to get a piece of pizza and you measured it with a protractor because you're very interested in knowing how much of the pizza you got, and let's say you got 72 degrees of pizza, and you know the pizza was shared evenly by some number of people, and you wanted to know how much of the pizza you got, okay? You would say, well, I have 72 of a total of 360 degrees of pizza. Okay, like the entire pizza was 360 degrees, and you had 72 over 360, which simplifies to 1/5. Okay, so you had 1/5 of the pizza. And this is what we're going to do. We're going to do the same thing, except we don't have numbers. We're going to have this value, x, for our different circle sectors. Okay, and we're asked to take this situation where we have this radius 1 of the smaller circle and this radius 3 of the larger circle. And we want to open this angle x such that area, we'll call this area 2 over here, is the same as, going to do this in orange, area 1. Okay, so start your work here with a very simple equation. And the equation might look like this. Area 1 equals, you guessed it, area 2. Okay, so once we've got that equation set up, it's just a matter of building an expression that has x on both sides and then solving for x. And we're going to be using these fractions to do it. Okay, let's work on area 1 first. Okay, area 1 is a fair bit simpler. So area 1, well, I'm taking an x-sized bite out of area 1, so that's a little tricky, but we're going to see it's not that bad. We're going to have pi r squared, which is the radius of the large circle. Okay, pi r squared. I'm actually just going to write 1 squared because I don't want to get into calling these r over here. 1 squared, that's the radius. But then I'm going to multiply that by some fraction of the total circle. And how much of this do I have? Well, I have 360 degrees minus x degrees. Like I'm taking these degrees out. So that's actually what I'm going to use. 360 minus x up there. Cool. All right. So now let's eliminate my scrawling. Okay. And now let's work on our expression for a2. Okay, a2 is actually, it's a little bit trickier in that I'm taking this bite, I'm opening up this x, but I don't have that first little bit of circle there. So what I'm going to have is, if I just wanted to do like the whole donut, if I wanted the area of this whole donut here, then I would do a2 is equal to the area of the big circle, so that's pi times 3 squared, minus the area of the small circle, pi times 1 squared. Okay? And that will give me the area of the whole donut. And if I take the area of that whole donut and then I multiply that by the circle sector that I'm opening up, that would be x on 360 is the fraction of that circle donut that I'm going to have. Okay, so now I've got my two expressions. Let's simplify them as much as possible. So I'm going to have here on this side 9 pi minus pi multiplied by x on 360. Not much else to do there. And then on the other side, I'm going to have pi multiplied by, geez, there's not much to do there. 360 minus x on 360. Really not much to do there. So let's do one more line. I'm going to have pi times 360 minus x on 360. There's just one thing I want to do on the other side, so I could have just done it, but my hand will not fall off if I do this. 8 pi, 9 pi times 8 pi, okay, and then multiply by x on 360, okay. Now, wouldn't it be nice if I could take away all the things that are common on both sides? So here's what I would do. I would go ahead and multiply both sides by 360, okay? Because when I do that, those 360s are going to cancel. And then I'm going to divide both sides by pi. And then here are the cancellations we get. Cancels, 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 cancels. Isn't that nice? Cancels, 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 cancels. Isn't that nice? Okay, so now we get this lovely equation, which is 360 minus x equals 8x. Cool. That we can solve, right? Okay, how do we do it? Well, our first step is going to be to add x to both sides. And then we get this nice new lovely equation, 360 equals 9x. One last thing to do is to divide both sides by 9. 360 divided by 9 happens to be 40 equals x. Dun, 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 dun. There is our final answer. Therefore, x is 40. So now you know, if you ever want to create this diagram where you have a, what does that look like? A Pac-Man there centered at O who's like barfing a cone. Anyway, if you ever want to create this picture, you need to, and you want the two areas to be the same, this angle here has to be 40 degrees. And that will do it. Okay, that's it for this one. Any questions, hit us up in the community. Otherwise, thanks so much for showing up for your math learning, everyone. Bye.